Hello and welcome friends. In this particular module, we are going to discuss about horizontal angle measurement in Theodolite surveying. It will be better if you are conversant with the terms that we have discussed in module 2C. In this particular module, we will be essentially discussing about the horizontal angle measurement by ordinary, repetition and reiteration method. We will also discuss about measurement of magnetic bearing as well as laying of the horizontal angle. After discussing each of the methods, how that particular data read can be presented in the field book will also be discussed. As you learn the content, you will be able to measure the horizontal angle by ordinary, repetition as well as reiteration method. You will also be able to lay off the horizontal angle. As well, you will be able to measure the magnetic bearing of a line. In order to measure these horizontal angles, there are three methods. First one is ordinary method, second one is repetition method, and third one is reiteration method. Before proceeding further, once again let's recall use of upper clamp screw and lower clamp screw. As we discussed in the earlier presentation related with the construction of a theodolite, we know that this particular equipment is provided with the leveling head, inner spindle, outer spindle, then upper clamp, upper tangential, lower clamp, lower tangential. As we see the sectional elevation, here you will be able to see this particular upper plate provided with vernier A and vernier B. This particular upper plate is related with this particular inner spindle, hence it rotates about the vertical axis shown here. Similarly, this particular lower portion is lower plate which provides the graduation from 0 to 360 degrees, and essentially that serves as main scale. There is a peculiar arrangement of this particular upper clamp and lower clamp and their respective tangentials. Here, when both the upper clamp and lower clamp are tightened, the instrument cannot rotate in the horizontal plane. Whereas, when this upper clamp is tightened and when this particular lower clamp is open, the instrument rotates about the outer axis. There is no relative motion between the two plates and the reading in the horizontal angle does not change. When the lower plate is tightened and when this particular upper plate is open, the instrument rotates on its inner axis with its outer axis fixed. Hence, the readings in the horizontal angle change. When each of the respective screw is clamped, its respective tangential screw can be operated in order to facilitate slower motion and exact bisection. The appropriate knowledge of using this particular upper clamp, lower clamp and the respective tangential screws is very much essential in order to use theodolite for horizontal angle measurement. Let's discuss the first method, that is ordinary method of measurement of horizontal angle. Say we wish to measure angle O, we wish to measure angle AOB. So we'll be setting the equipment exactly at O. We'll be carrying out all the temporary adjustment, that is, we will level the equipment, we will center the equipment, as well as we will focus the equipment. So all this particular temporary adjustment already we have discussed in our earlier presentation. For exact centering, we wish to make use of the shifting head. So here the way you see here, this wavy kind of wheel is clamped, whereas the small circular plate is detachable from this particular head, and accordingly here we can slide this particular equipment bodily on this particular base. As such, the shifting head arrangement can be used for exact centering the way we discussed in our earlier presentation. So say we have set the equipment exactly on station O and the equipment is ready to take the readings. So in order to measure this particular angle, now the first step will be to loosen the upper clamp as well as the lower clamp. We will rotate both the plates simultaneously in opposite direction to each other, so that the zero provided on the vernier plate will be exactly coinciding with the zero that is provided on the main scale. So as this is roughly facilitated, we will clamp the upper screw. Then we will make use of upper tangential and we will have the exact coinciding of the index of the vernier and the zero mark that is provided on the main scale. Now we will move the equipment, we will rotate the equipment in such a manner that the telescope will be directing towards A. As we have approximate bisection of A, we will clamp the lower screw. Then by making use of lower tangential, we will have the exact bisection of this A. So at this particular instant, we will be directing the telescope exactly at O. We will have both its upper plate as well as lower plate in clamp position. Equipment will be exactly centered over station O. Now we will release the upper clamp and we will rotate the equipment in such a manner that the telescope will be bisecting station B approximately. At this particular moment, we can clamp the upper screw, make use of upper tangential and have exact bisection of this particular station B. As such, now the angle AOB can be read. Here, two more things to consider. As we set the equipment towards A, we have to take the reading of vernier A. Here, the vernier A should be giving the reading of 0 degrees, 0 minute and 0 second. Whereas, as we read the opposite window, that is vernier B, it should be giving a reading of 180 degrees. If that particular window is not giving reading of 180 degrees, 0 minute, 0 second, there is a need to have the reading recorded in order to apply the correction subsequently. Second thing is, usually whenever we wish to measure the angle such as AOB, initially we keep the vertical circle on the left side of the observer. That is, while sighting the station A, we will be keeping the vertical circle on the left side of the observer. As such, the condition maintained will be face left condition. So, we wish to measure the reading now. The way you see in this particular left image, these are the actual graduations. The upper part that you see is vernier scale, whereas the lower part that you see is nothing but the main scale. Before actually using this particular equipment, if you are using the equipment first time, it is better to determine the list count of that particular equipment. As we discussed in earlier presentation, list count of the equipment is nothing but the ability of the equipment to measure the smallest fraction of the angle in simple words. It can be determined by dividing value of the smallest division on the main scale by number of divisions on the vernier scale. Here, the smallest division on the main scale is of 20 minutes. Whereas the way you see for this particular vernier, main graduations are seen to be 0 to 20 minutes, whereas each of the minutes is divided into 3 parts. Hence, here the smallest division on the vernier is of 20 seconds. The number of divisions on this particular vernier scale will be 20 into 3, which is nothing but 60. Hence, 20 by 60, which is nothing but 1/3 minute, which comes to be 20 seconds. Having known this particular, say, list count, here one can measure the angle in the multiple of that particular 20 seconds as one is following this ordinary method. Initially, refer to the main scale. The way you see here, this particular division is representing 10 degrees, whereas here the next division is fully covered up to the index mark. Hence, this particular main scale reading should be 10 degrees 20 minutes. Whereas, as you see the next division, you can see about, say, 40 to 50% of that particular division is covered. That means the reading should be near to about, say, 10 minutes. The way you see here, we can see, say, 6 minute, 7 minute, and here this 8 minute division is coinciding exactly with the main scale division. Hence, the reading here is 8 minutes. As such, the total reading is 10 degrees 28 minutes. Say, instead of this particular division, if the next division was coinciding, the reading would have been 10 degrees 28 minutes 20 seconds. Here, just we are trying to understand simply the reading of the graduations. As you take such kind of the reading on Vernier A, now the Vernier B is to be read simply in minutes and second. As such, Vernier A will give us reading in degrees, minute and second, whereas Vernier B will give us reading in minutes and second. As we have the average of both the readings, it will give us the total reading pertaining to the angle that we wish to measure. So, after having this particular angle read, it needs to be recorded in the field book. We can follow a number of such, say, recording patterns, but the one that I am trying to show is easier to understand and one can make use of this very comfortably. Let's see, the first column is representing here the instrument station. The second column is representing station to site, whereas this particular left part is associated with the face left, this particular right part is associated with the face right, and at the end what we see is nothing but average horizontal angle. As we discussed previously, we wish to measure angle AOB. Equipment is set at station O. The graduations on the horizontal plate are in clockwise direction from 0 to 360 degrees. That means initially we have to sight to the station which is provided on the left side of the observer. Hence, always will be having the swing on the rightward direction. So here if there is a face left or if there is a face right, the swing associated is towards right only. Initially, equipment is set at station O and the reading is read with respect to station A. As we have set both Vernier plate and the men's scale in order to read 0, 0. If there is nothing wrong with the graduation patterns, all the readings pertaining to this particular station sighting to A will be 0 only. Whereas, as we sight the station B, the way we discussed on the previous slide, say Vernier A reads 36 degree 23 minute and 20 second, whereas the Vernier B, which is to be read simply in minutes and second, is reading 23 minute 20 second. Hence, as we have the mean of both the readings for face left condition, the angle will be 36 degree 23 minute 20 second. Here we are reading this particular angle once only, hence the repetition will be 1. Hence, with respect to these particular readings, the horizontal angle for face left condition can be presented as 36 degrees 23 minute 20 second. All the operations that we did with the face left condition can also be done with the face right condition. Here, this particular vertical circle will be on the right side of the observer. So, Vernier A 36, 23, 40, Vernier B 23, 40, mean is 36, 23, 40. Here again, the repetition is 1 and the horizontal angle can be presented as 36 degrees 23 minute 40 second. As we have the mean of both the angles that are read with face left condition and face right condition, the average horizontal angle can be presented as 36 degree, 23 minute and 30 second. Next method is method of repetition to measure the horizontal angle. This method is used for very accurate works. In this method, we add the angle several times mechanically, and the correct value of the angle is obtained by taking average of some of the readings that are taken over the number of repetitions. Here, usually the number of repetitions are 6, 3 with face left condition, whereas 3 with face right condition. Let's assume that we wish to measure this particular angle AOB. So, the way we discussed previously, we'll be setting the equipment exactly on station O. We'll be carrying out the temporary adjustment. We'll be setting vernier A to have reading 0, 0. We'll be keeping the face left condition, and with face left condition, we'll sight initially A. By making use of appropriate screws, we'll sight the station B, and hence we'll take the reading of AOB, and we'll have the recording the way we discussed on the previous slide. After sighting this particular station B and after recording the reading, now we'll release the lower clamp. As we release the lower clamp, the equipment will be rotating on its inner axis, and as you know, there won't be change in the graduations. So the equipment will be rotated and will again sight station A. We will clamp the lower one. We'll make use of lower tangential and we'll bisect station A exactly. Again, we'll release the upper clamp and we'll rotate the equipment in such a manner that we'll bisect station B exactly by making use of the upper clamp and upper tangential. After having this particular exact bisection, once again we will release the lower clamp, we will rotate the equipment, and again we will have the telescope oriented towards A. We will have the exact bisection with this particular station A by making use of lower clamp and lower tangential. Once again we will release the upper clamp and we will have this particular angle AOB read third time. Hence, we are having 3 times repetitions in order to measure this particular angle AOB with face left condition. Same thing now we can have with face right condition. So here angle AOB will be read with face left thrice and with face right thrice. Here, these particular slides indicate the recording of this particular horizontal angle measured by this particular repetition method. The upper row is giving the similar meaning of the entries, that is instrument station, sighted station, face left, swing right, face right, swing right, and the average angle. Instrument station is O, the sighted station is A. Initially, there is no change in graduation. Equipment is free of any errors pertaining to the graduations. Hence, all these particular entries will be 0, 0. Whereas as initially as we sight face left, here the angle pertaining to station B is 36 degree 23 minute 20 second. At the same time, Vernier B reads 23 minute 20 second, hence the mean is 36 degree 23 minute 20 second. This is our first repetition. Hence, the angle can be presented as 36 degrees 23 minute 20 second. Here, as we loosen the lower clamp and again sight the station A, there won't be any change as far as the readings are concerned. But as we sight station B again, angle will be approximately twice. So the way you see here, angle is 72 degrees 46 minute 40 second. Here, Vernier B reads 46 minute 20 second. Hence, this particular average can be presented as 72 degrees 46 minute 30 seconds. This is our second repetition. Hence, as we divide this value by 2, we will be getting the horizontal angle as 36 degrees 23 minute 15 second. Again, we release the lower clamp and again we sight the station A. Hence, there won't be any change in these particular graduations. If at all there is a change in the graduations and the respective readings, we can conclude that there is slip, which is nothing but the instrumental error for that particular theodolite. So, when we have this particular third repetition, angle will be nearly thrice. So, the way you see here, the horizontal angle worked out is 36 degrees 23 minute 23.3 seconds. Same thing, whatever we did with the face left condition, we have done with face right condition, and the data is appropriately recorded here. One thing to note here, that the list count of the equipment is 20 second, but the way we are getting the meaning is 10 second, 23.3 second, 21.25 second. That means after having these particular kind of the repetitions, we can read the smaller fraction of the angle as compared to its list count as we have the repetitions and the averaging out for that particular angle. This method of the repetition eliminates different errors present in the measurement of horizontal angle. The error due to the eccentricity of the verniers and the centers gets eliminated as we take the readings from both the verniers. As we discussed previously, when we read vernier A, vernier B simultaneously should be giving the exact difference of 180 degrees. But if that difference is not exactly of 180 degrees, that means the inner spindle or outer spindle could be tilted, as such it has got eccentricity. Or otherwise, the graduation pattern could be erroneous. So some such kind of the error due to eccentricity of the vernier as well as the center get eliminated as we read both the verniers. As well as at each of the time, the way you see, we read the angle as 36 degrees, we read the angle as 72 degrees, we read the angle as 109 degrees. So here we are reading for 3 subsequent repetitions different part of the main scale. Hence, if there are certain inaccurate graduations, the error due to these will also be eliminated. As we have the line of sight, say, out of its true position, or if the axis of that particular telescope if is not with the requisite relationship, the error pertaining to that is also getting eliminated. This is because we are taking the reading with both the face, that is with the face left as well as face right. The error due to the inaccurate bisection of the station eccentric centering can also be eliminated partially as it is getting counterbalanced in different observations. However, if there is certain mechanical slip, if there is certain, say, some sinking of the station, or say sinking of the tripod, or if this particular signal is not exactly bisected, the error pertaining to that does not get eliminated and it is cumulative in nature. The next method is method of reiteration. This particular method is very useful when we wish to take the reading from a single station with respect to various radials starting from that particular station with respect to the stations circumscribing the instrument station. So here the instrument station is O, whereas from this particular station we wish to take reading pertaining to station A, station B, station C and say station D. As such, we wish to take the angle AOB, angle POD, angle DOC, angle COA from the same station, from the same instrument station. Here the angles are read with respect to one reference only, hence this station A should be chosen as dominant station and regarded as the reference station. In order to have this particular, say, readings read, we are starting from A and we are coming back to station A. Hence, as we are starting from the station, same station, and as we are coming back to that particular station only, the method is also called as closing the horizon. It is also called as method of direction, or as we measure the angle in series, it is also called as method of series. So, in order to measure this particular angle by reiteration method, initially we will be setting the equipment exactly over O, we will be sighting station A appropriately, we will be clamping the equipment with respect to station A. Now we will release the upper clamp, we will sight the station B, we will clamp the upper. By making use of upper tangential, we will have the exact bisection of station B and we will read the angle AOB and record the same. As we record the angle now, again we will be releasing the upper clamp and we will be sighting this particular station D and we will record the angle the way we discussed previously. So here the same procedure will be continued till station A. As we reach to station A, the angle should be 0, that is 360 degrees. If at all, if this is not 360 degrees, that means there is some observational error. As well, there could also be slip of the circle. That means there could be instrumental error or there could be certain, say, personal error. If this angle, say now here we are measuring this particular angle 4 times. If in layman's language we speak, the surveyor may commit the mistake, say, to the tune of its least count. As such, the angle total sum could be 4 times 20 second in positive or negative manner if it is not compensated. So, if this particular error is lying within this permissible limit, then it will be equally distributed in each of these particular angles. If the error is not lying within the permissible limits, then the readings will be totally discarded and the work will be started afresh. So this particular table tells us about how that particular readings can be, say, recorded. Similarly, instrument station is O, sighted station is A here. All that particular readings are 0. As we sight this particular station B and as we record the reading, it comes to be 36 degree 23 minute 20 second as mean of vernier A and vernier B. Hence, angle AOB will be 36 degree 23 minute 20 second. As we sight the station C, here the angle read will be angle AOB plus angle BOC. Hence, it comes to be 96 degrees 27 minute 20 second. Difference of that will be 60 degree 4 minute 0 second. In the similar manner, here angle COD is 176 degrees, whereas angle DOA is nothing but 87 degrees 13 minute 0 second. The way we have determined the angle with the face left, in the similar manner we have determined the angle with the face right. As we close the horizon, we'll be having the total sum of this particular average horizontal angle. It comes to be 359 degrees 59 minute 35 second. As we deduct the same from 360 degrees, here what we get is nothing but the difference, which is nothing but the discrepancy in closing the horizon. As we have measured 4 angles from station O, it can be distributed equally as it is lying within the permissible limit, and the extent to which it should be added through each of this particular angle is nothing but 0 minute 6.25 seconds. The angle measurement methodology can also be extended, or it can be discussed in terms of reading magnetic bearings. As you learned in compass surveying, magnetic bearing is nothing but the horizontal angle measured with respect to magnetic north. So here, now say instead of having A as a reference object, we'll be having the reference direction of the magnetic north direction, and with respect to that particular magnetic north direction, we'll be measuring the angle rightward for a line under consideration. So, in order to have this particular bearing measured, we have to have the magnetic north direction. So, in order to have that magnetic north direction, the way you see here, we can make use of certain trap compass. So, here this is A frame. With that particular A frame, we are provided with these particular, say, 2 housings where this tubular compass can be attached. So through this particular eyepiece, now we can sight and we can have the 0 direction of that particular magnetic north once this particular clamping screw is released. Instead of this particular tubular trap compass, we can make use of circular compass also. So here both kind of this particular attachment be used in order to define the magnetic north direction. Now, in order to have that particular initial reference set, here we will have the upper clamp and lower clamp to read 0, 0. We will be clamping the upper screw. We will be loosening the lower clamp. We will rotate the telescope in such a manner that the line of sight will be lying in the direction given by this particular magnetic needle. As we get that, then we will have the lower clamped, and we will have the exact bisection by making use of lower tangential. Hence, now the telescope will be oriented in this particular magnetic meridian. As we do so, we can make use of upper clamp and we can release the screw in such a manner that the telescope can be rotated towards the station P, and hence as we clamp the equipment towards P, as we have the exact bisection, now the angle can be read with respect to line AB. This angle is nothing but the magnetic bearing of the line. This is very essential technique as far as theodolite traversing is concerned. Now, instead of measuring, say, if we wish to lay off the angle, we have to follow the reverse of the procedure that we discussed about the horizontal angle measurement. Say for example, now with respect to line OA, we wish to define this particular station P in such a manner that angle AOB is 10 degrees 28 minutes. So here initially we'll set the vernier A and set the vernier A with its main scale in such a manner that the angle will be set to 10 degrees 28 minutes. Hence, here this division will be set with respect to this particular index in such a manner that main scale will be given 10 degrees 20 minutes, whereas this 8th division will be coinciding exactly, and at this instant will be clamping the upper screw. So we won't disturb that particular arrangement when we'll be making the line of sight bisecting this particular station A with the angle 10 degrees 28 minutes. So here the upper clamp will be released and will rotate the telescope towards B in such a manner that the main scale and vernier scale will be giving us 0 degrees 0 minute. As such, here we can have that particular reading read on vernier A. Vernier B, the reading will be 180 degrees. At that particular instant, we can clamp the equipment. The telescope is now oriented in the direction of B. So at the requisite set distance, station B can be defined with respect to O. So this particular method will help us to lay off the angle. So thank you very much for your attention, friends. I hope all the concepts that we have discussed here are clear to you. In the next presentation, we will discuss about vertical angle measurement in theodolite surveying. So bye till then, I wish you very happy learning. Thank you.